I'm back. Hi, Erica.
Hello.
Toby, you're back. Okay, who is Carl? Who is Carl?
Your mom.
I'm sorry?
Your mom.
I'm not understanding you.
Your mom.
My Rob?
Your mom. Croissant.
Put it in the chat. Type it in the chat, please. I'm not understanding you. I'm removing Carl. Sorry, guys. Are we all there? Unmute yourselves. Thank you, Ryan, for unmuting. Are we all there? Sorry, I had to deal with there. Apparently, I did get somebody in.
Yeah.
So unfortunately, I couldn't understand them and they didn't type a reasonable response into the chat room. So I basically removed them. Okay, we good, guys?
Mhm.
Yeah.
Yes.
Okay, all right. General message. I'm gonna have another meeting this afternoon at 2. There were some problems with Tuesday's lab meeting at 2. So if you were in that meeting, I'm going to extend an invitation to you for this afternoon at 2. I'm sorry, but what happened was they gave me information, but they didn't tell me how to apply that information. So because of that, I was confused when I went to talk. I thought that things were going to be done one way. Apparently they're done another way. As a consequence, what happened is I didn't give as good a presentation. Then I came back on, told some people the information. So if you're still confused, log on. I will extend an invitation at 2. If you're still confused about what's going on in the lab, log on at 2. I will go through it with you again. Are we good?
Yes.
Yes.
Okay, let's go back to sharing screen. Are we good? We see this, guys?
Yes.
Yep.
Okay. Very important slide. All right, if you don't want to think through, if you don't want to take this equation and think through what all is happening, just memorize this, guys. There are only 4 conditions that you have to memorize. So you're going to have this in order to, this would be an important thing for you to have around when you're taking the test, okay? So if you got an exothermic reaction, a negative delta H, and your delta S is positive.
Almost lining up for the disaster. Here's what you need to know. The technology uses Bluetooth radio.
Whoa.
facilitate
Is somebody,
earbuds. The problem is that the iPhone won't be connecting to both earbuds.
thank you. I don't know what's happening, but somehow somebody's doing something on the computer. I don't know what's happening there, so. All right, so if your reaction is exothermic and you have a gain in entropy, your negative delta T delta S is always going to be negative, so your G is going to be negative. It's spontaneous at all temperatures. If your enthalpy is endothermic, it's positive, and your delta S is negative, then your negative T delta S is always going to be positive. Your delta G will always be positive. It will be non-spontaneous at all temperatures. If your delta G is negative, if your enthalpy is exothermic and your delta S is negative, you're losing entropy, then your negative T delta S is a positive because these two terms are different. Your delta G can be a positive or negative. It's going to be spontaneous at low T, non-spontaneous at high T. If your delta H is positive, if it's endothermic, and your entropy is increasing, your negative T delta S is negative, that means this term can be, your delta G can be positive or negative. That means you're spontaneous at high temperature, non-spontaneous at low. We have a good handle on this because we're going through a couple problems. Okay, you have an endothermic reaction. You have 8 SO3 gases going to 1 S8 solid plus 12 O2 gases. What's the sign of delta S? Sabrine. I'm sorry, I didn't hear you, Sabrine. It's going to be positive. So my delta H is positive, my delta S is positive. If I go back to my previous slide, delta H is positive, delta S is positive. What conditions, Sabrine, is my reaction going to be spontaneous? Julia.
With a high temperature.
If I have a high temperature, it's going to be spontaneous because my T delta S point is going to be negative. It will overcome my delta H. Sorry about this. Consider the reaction. 1, sodium sulfite reacting to make, or dissolving to make 2 sodium ions and 1 sulfite ion. It's an exothermic reaction. Let's go. Caitlin with a K. You there?
Yes, I'm here.
Caitlin with a K.
Yes.
Is the delta S going to be positive or negative?
It's going to be positive because you're going from basically 1 mole of something to 3.
Kind of, sort of, but you're
Kind
right.
of, sort of. And like you're going from a solid to an aqueous solution.
You're going from a solid into dissolving it. That always is going to be a positive delta S. So we have a negative H and we have a positive delta S. Remember the equation. Delta G is equal to delta H minus T delta S. Under what conditions will this occur spontaneously? Remember, we're dealing with this equation. You just said this was exothermic, so this is going to be negative. You said your delta S is positive. So we got a negative delta H, a positive delta S. Caitlin, under what conditions is it going to be spontaneous?
Spontaneous at all temperatures.
Exactly. That means basically it doesn't matter the temperature. If you put sodium sulfite in water, it's going to dissolve. Are we okay with these guys? Do we have an idea of what I'm trying to get you to do? Because I can
Yes.
almost guarantee, I can guarantee you, you will have some of these problems on the test.
So I have a question.
Absolutely. Who is this? Naima?
This is Naima. To the previous slide before that, with the
Okay.
exothermic reaction. So how do you know like where to put, like I'm trying to imagine.
Is this the equation you're talking about?
Yes.
Okay.
So I'm trying to imagine myself seeing like the delta H, either minus the delta T with the delta S.
Okay.
Like where to place those so I can be able to.
Okay, let me try and do something. Let me see if I can get in show and get in here. If I'm able to, I will try. The overall reaction is delta G is equal to delta H minus T delta S. Okay, Naima?
Mm-hmm.
All right, it's exothermic. The sign of this is going to be negative, okay?
Okay.
Because you're taking a solid and dissolving it, that always results in a positive entropy change, okay?
Okay.
So I got a negative number and I'm subtracting T times a positive number. So I get a negative minus a negative. Delta G has to be a negative number. Does that make sense to you, Naima?
So a negative, like, so can you re-say that again?
Delta H is an exothermic reaction. Because of that, the sign of delta H has to be negative. So this term
Okay.
is going to be negative. From this term, I'm subtracting the temperature. Temperatures in Kelvin, it's always going to be a positive number. We just determined from this reaction that delta S was positive. So I've got a negative number, I'm subtracting a positive number from it. That always will result in a negative number being formed. Do you see that?
Okay. Mm-hmm.
Because that's always going to be negative, delta G is going to be negative. It doesn't matter what the temperature is. Okay?
Okay. Mm-hmm.
Okay. I need to go back to slideshow. Okay, are we good, guys? Are we good? We have an understanding of what we just went through.
Yeah.
Yes.
All right. Now we're going to get into the calculations, and from here to the end of the lecture on Tuesday, we're going to be doing calculations. I'm hopefully going to get done with the calculations by the end of the first lesson, the first Zoom meeting on Tuesday, so that I'll just open up the second meeting as a forum for you to ask questions. Fair enough?
Fair
Our,
enough.
our test is a week from today, and I still have to make it up. So bear with me. I will, even if the test is long, and you guys know I tend to make long tests. Even if it's long, it will be curved. I promise you that, okay?
Okay.
Okay.
All right. Now, I've got to deal with delta G0. Delta G0, whenever you see this little degree sign up here, that means we're under standard conditions, okay? So
Okay.
I want to find the delta G for this equation at 25 degrees Celsius. I can look up in a table. Remember the tables at the back of the book? I can look up in a table and find the individual delta G zeros for, the delta H zeros for S, the delta S zeros for S8 Cl2 and S2 Cl2. I can find those all up by looking in a book. So the strategy I'm going to use is I'm going to use Hess's law to figure out what my delta H is. I'm going to use Hess's law to figure out what my delta S is. I'm going to then take my delta H and subtract multiplication of the temperature, 25 plus 273, 298 times what my delta S0 is. Straightforward problem. If my delta H's are negative 18.4, I think the second one is a positive 102.3. And because, guys, remember, when we're dealing with delta H's, the delta H for an element, the delta H for an element in its natural form is going to be 0. Okay? That's for delta H's. Delta S's, that is not true. So if I'm dealing with this, I've got my entropy or my enthalpy for my disulfur dichlorine. I've got it for my chlorine and I've got it for my S8. I simply I multiply the coefficient times my enthalpy of my S2 Cl2. From that, I subtract my 1 times my enthalpy for my S8. And then I add 4 times 0. That's my enthalpy for my Cl2. I do all this up. I have a negative 28.7 kilojoules per mole. Remember, delta H's are in kilojoules per mole. I do the same thing. I look up my delta S's for my S2, Cl2, S8, and Cl2. Remember, this is not 0 when I'm dealing with delta S's. So I do this again. I'm going to multiply this one by 4. I'm going to multiply this one by 4. And this one, I'm just going to multiply by 1 because those are the coefficients. Erica, you there?
Yep.
You got my message in the email about the quiz, right?
Yeah, I did.
Okay. Yes, there was a problem with the labeling. I freely admit that. And I'm sorry if my tone was bad to you. But
No, it's okay. I understand.
the important thing is that you now know that you have to multiply it by the coefficients, right?
Yeah.
Okay. So I do this math out, guys. I multiplied 4 by the 331. From that, I subtracted 1 times 430 and 4 times 223. I do that math out. And I end up with a change in entropy. I have a positive entropy of 3.8. I now plugged in my enthalpy that I got from Hess's law into the delta H. I plugged in 298 times my entropy plugged in. Now, something you have to realize. Delta S's are in joules per mole. Delta H's are in kilojoules. So you're going to have to, when you do this equation, you're going to have to convert it. Guys, delta G's are reported in kilojoules. So you have to convert the delta S's from joules to kilojoules. So that's what I did here. So I've got negative 28.7 minus 1.1. That ends up with a negative 29.8. Is this spontaneous, guys?
Yes.
Yes.
Negative delta G, it's spontaneous. Main thing about this, again, change the delta S to kilojoules, because the delta G is also reported in kilojoules. Another problem, we're going to do the same thing. Find delta G reaction and spontaneity at 1055 Kelvin. Same strategy. We're going to use Hess's law to find delta S and delta H. I'm going to plug that into the formula. And once I plug it into the formula, I'm going to have my answer. Do you want me to let you work on this? Would that be beneficial to you, or do you want me to just go through it?
I would like to work on it and see what we come up with and like how we got the answer. I don't mind.
Okay, that's going to take you, it's going to take you about a good 5-10 minutes.
Okay, then
Does anybody object to that?
Can we go through it together?
We will go through it together after. That fine enough? Julia, is
Yeah.
it Julia?
Yeah,
Is that fair enough for you?
fair enough.
Okay, give it a shot, guys. I guess, wait a second, I think you need. Oh, sorry, previous. You need these values, okay? I'm just going to take off for a second or two. I'll be back in a moment. By the way, guys, you can use the chat room to help each other, or if you unmute your mics, you can also use that to kind of help one another. Okay, you out there?
Yes.
Okay, I managed to finish the jumble in that time. How we doing? We finished or you want some more time?
I'm finished.
Sorry if I took so long. I promise to do the jumble quicker next time. Did you like the picture of the dog? Did anybody notice?
Yeah.
Yes.
Yes.
Yes, I love the dog. Thank you.
Good, you want her?
Not particularly.
I mean, if you're offering.
Yeah, she's yours. Come on over. All right, what I got, I ended up, my coefficients, I believe, were 1 to 1 to 1, so I don't have to worry about multiplying by anything. So when I'm doing Hess's law, I'm doing this, the 2. Yeah, I keep on pointing and you guys can't see me pointing. I got the 2 products minus the reactant. I ended up getting an endothermic reaction. We good?
Yes.
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 I did my delta S's. I ended up with a positive entropy, but I converted that. Guys, are you still having to go through and the thinking of the labeling? Are you comfortable just taking this directly and dividing it by 1,000 in your head and moving it 3 places over? Anyway,
I usually just move it 3 places over.
that's fine. Well, obviously, with a multiple choice test, I'm not going to be checking for your work anyway, so never mind. Anyway, I had to change this from joules to kilojoules because I want to convert the delta G into kilojoules. I end up doing this. I get this times this, these 2 together. I do that math together, and I end up with a positive 10.2 kilojoules. It's non-spontaneous. Are we good, guys?
Yes.
Yep.
Was that helpful?
Yes.
Yes.
Did I give you too much time?
No.
No, I don't think so.
Okay. Another problem. This is might be the last problem we deal with. At what temperature is the following reaction spontaneous? I am not bothering to make you do the Hess's law here. I'm giving you what the enthalpy is, and I'm giving you what the entropy is. Think back to algebra, guys. I want to know at what temperature the following reaction is spontaneous. Okay? Anybody have a possible solution for me? Okay. Understandable. I'm hearing crickets out there.
Do you
So-
solve for K?
Yes, that's exactly what you're doing. But Toby, you have the formula. Delta G is equal to delta H minus T delta S, right?
Mm-hmm.
You have 2 variables. You don't know what the delta G is, and you don't know what the temperature is, right?
Mm-hmm.
All right. But where does a reaction become spontaneous?
When delta
What
G
has
is
to-
less than 0.
Exactly. So if we set the equation, if we set delta G equal to 0, that's going to determine what temperature it has to be in order to get delta G to equal to 0. Any temperature higher than that is going to make the delta G negative. Did that make sense to you all?
Yes.
I think so. Yeah.
So we're going to, in order to do this, we're going to set this up so that we're going to get the delta G equal to 0. We now have one of the variables gone. We can solve for the other variable T. If I do that, if I set it to 0, remember that was my enthalpy. minus T times, I had to change my entropy from joules to kilojoules.
Mhm.
Okay. I took, for some reason or other, I took this over here and made it negative. Okay. I divided it and I got, this is my temperature. I simply, at that point, then took my degrees Kelvin, subtracted the degrees Celsius from it, or degrees, the conversion, guys, and I ended up with 146 degrees Celsius. What this means, if my T, my arrow, if my T is larger than 146, any temperature larger than 146, then that's going to mean that this number is going to be less than 0 or negative. That means my reaction is going to be spontaneous. Are we good there? See the
Yes.
logic behind that?
Yeah.
All right. Just wanted to use this slide to point out some things. And that is that delta G, like delta H and like delta S, is a state function, which means that we can look up these values in a table, or we can calculate them if we're given delta S's and delta H's. Remember, for delta H's, pure substances are 0. If delta G is negative, if we're dealing with an equilibrium here, guys. If delta G is negative, then the forward direction is spontaneous. If we're at 0, the system is at equilibrium. Now, if delta G is positive, what do you think is going to happen? Well, we sure know it doesn't go in the positive direction, right? Doesn't go in the forward direction. If delta G is negative, I'm sorry, if delta G is positive, what can we say about the reaction? It's going to be spontaneous in the other direction. Okay, guys, we got about 5 minutes left, and I think I've overgone my time anyway. I'll stay on the meeting for any questions about what we've gone over today. Remember, we've got the very important thing we went over was the equation delta G is equal to delta H minus T delta S. We were looking at different circumstances whereby we could tell what the sign of delta G was. From knowing what the sign of delta G was, we were able to determine whether it was spontaneous or not. We derived that equation, delta G is equal to delta H minus T delta S. We just went through a couple of equations using that particular formula, and we went through one formula where we discovered what the temperature had to be. At this point, guys, and last thing, if we're dealing with a sample in equilibrium, if delta G is negative, it is spontaneous in a forward direction. If delta G is positive, it's spontaneous in the reverse direction. If delta G is 0, we're at equilibrium. Now, guys, I'll throw it open to you. Anything, does anybody have anything? Any questions?
I mean, sorry.
Question about
Sure.
this, but I have one about like the exam. I remember you sent out an email in the very beginning when we first started online
lied.
classes.
I lied. What did the email say?
I would have to honestly look at it to like exactly recall, but I just wanted to know, like with the test, are we supposed to, you said that we're not using a cheat sheet on the test anymore?
That was a joke, okay?
Okay.
That was a joke. All right.
So we can still
Literally
use our
speaking,
cheat sheet.
right now, if you open your screen, how am I going to be able to tell what you have on your desk?
Well, I don't
I-
know.
I believe what I told you was it was an open book test, right?
Yeah, but I just wanted
And
to
that
make
you-
sure.
Yeah, I said it was an open book test, but that you could couldn't use the cheat sheet. I was
Oh,
being
okay.
funny, okay?
Okay.
Yes, you could, if you want it, if you want to copy everything down into a cheat sheet, you can have it. But I'm just flat out saying you can use an open book. Fair enough?
Okay. Yes.
Toby, I believe you had a question.
Yeah, so I see in the top left of the meeting it says recording. How do we
Yes.
access the recording?
Beats the hell out of me. Okay, Toby, do you see what my second note says? Uploading
let me get a-
recording. Okay. I've got to call somebody today. I believe I've got them saved. I just don't know how you access them. Okay. I
Okay.
believe.
Okay, so they're saved to your computer and not mine?
Yes.
Okay.
As if this, somebody said I had to start up a YouTube program. That may be very well what I have to do. I don't know.
Okay, thank you.
I have a question about the lab.
Okay. Who is this?
This is Shannon.
Hi, Shannon. What's going on? Is it Shannon? Do you have me today, or do you have me? Did you have me on Tuesday?
I have you today,
Okay, go for it.
but do you know how long it's like supposed to go? Like,
That depends
half
upon
hour?
you. I really don't
okay.
want to go longer than 2 sessions, but there are some things you need to know. Somebody pipe in and say somebody that had it on Tuesday, either the afternoon or the morning, afternoon or evening, pipe in and say whether you desperately need to do this, to go to the meeting. I'm hearing crickets.